So the next step is let's add some more shapes to our ShapeMaker ISF file. I've got just a blank ISF editor here, screen, and actually if you come to the ISF editor and you say New ISF File, what the ISF editor will do is actually give you just kind of like some boilerplate. And actually I'm going to clear most of this because I don't need it. I'm just going to reduce all this, and we'll just type in vec 4 and 1.0 for now, and I'll get rid of some of this JSON as well, just up to the inputs, because we're not going to have any inputs just for this demo. And I'm going to save this as rect. Let's just work in a separate rectangle fs file for now, and then we can integrate that back in with our code later once we've written some of our shape functions. So up to this point we've got an ellipse going, an ellipse function, and what I'd like to do is extend this with a rectangle function. Okay, so when I was building my rectangle function, I was able to kind of puzzle my way through a simple rectangle, and so I'm going to share that code with you. And then if you go in Book of Shaders, there's a code library that's been contributed by some pretty smart programmers, and we'll go through some of those. So let's look at the basic idea first. Let's go through the simple drawing of a rectangle on screen before we implement a little bit more sophisticated code. And it's actually it's pretty easy to take what we've learned from before with using the step function to create something like a band or a bar. So let's go ahead and let's do that. Let's create our screen space. And I'm going to do some of the same stuff that we've done up to this point. A screen space is ISF frag norm chord, and then I'm going to create a color of the X. I'm going to just visualize the color X. And let's make float color be equal to screen space dot X. And then right down in here, let's create a vec3, and we'll put color in there. And sure enough, we can see now our gradation from left to right. The next thing I'm going to do is I'm going to move it up and to the right so that we'll put 0 at the center of the screen. There we go. And in the past, we've ran length on this. We've ran length on screen space. But now we're going to introduce a new function. This one's called absolute. And absolute, essentially what it does is it just returns numbers without their negative signs. It's actually a pretty simple concept, right? The absolute value means like the total quantity, whether it's a negative or a positive. So as an example, if I was to give absolute negative 5.0, it would return just 5. If I was to give it 5.0, it would also return 5. Absolute, though, we can also feed it vec2, vec3, vec4, and get useful results that way. But for now, let's just go ahead and let's take that screen space of X, and let's get the absolute value of the screen space of X. So remember, we're going to no longer return any negative values. I'm going to bump this over and bump this over a little bit too, just so it's a little bit easier to see the results of my code on the left here on the output window on the right. And sure enough, check that out. So as you can see, there's basically no negative numbers, right? So as it starts going from 0 and counting up this way, it also starts going from 0 and counting up that way. And we could do this on Y as well. And I'm sure you probably see also where we're going with this, right? All we have to do is combine this with our friend step. And I'm just going to step at, 0.1, say, and that creates a band. And then right away we could bring this, to a, let's call this a band function. And actually, before we do, we'll come back to that. Let's actually just make this be really simple. Let's just do band right there for now, and then let's just make another one of band 2, and let's make that be equal to the Y. I could make a band function, but I think this will be simplest enough to see just here. And actually, even before I run step, let's just see what happens when I combine both X and Y together. Like I've got band and band 2, and if I just add them together, I'll get something that looks like that. And so all those white values are going to be additive, and we get something that looks like a star. And then, of course, yes, if I step these values, if I step both of them, like say 0.1 or 0.2, and I add them together, this yields my rectangle, this is my horizontal, and this is my vertical. So now let's go ahead and let's actually, rather than build, we could just build a band function that just returns these things, but I think I'm just going to package it all together, and I'll make a rectangle function. And what it's going to do is all of this stuff. We'll go ahead and copy and paste it up there. And then we'll just return band 1 and 2. And then we're going to pass it. We need to pass in a screen space. And then down here, we should be able to replace all of that with, let's call our float rect is equal to rectangle, and we'll pass in screen space. And then down here, we don't need that anymore. Let's say rect. Let's save, and sure enough, it's the same. And to create just some useful variables for this, let's create a width and a height. And then right in here, we can replace those numbers with width and height. And then in here, these then are values that we can, we can make these be up here as sliders if we want. We can adjust these, and we got ourselves a nice controllable rectangle. Okay, so so this is what I had actually initially in the code, and this is kind of also something that I could kind of puzzle out. Now let's go ahead and let's take a quick look at what these guys have got. So right here inside Book of Shaders, there's a examples gallery, and in the examples gallery, there's a really useful, let's see, a very useful file for us here, the distance field shapes. I'm going to come in here and check out what they've got here for distance field shapes, and I noticed that their rectangle, let's take a look at their formula for a rectangle in here. These are courtesy of kynd.info, kind on Vimeo. Very, very cool generative work. Check out all this stuff. Really, really, really nice stuff. So kudos. I don't know who this person's name is for attribution, but you can go to kin.info and check out more. This, I noticed this rectangle formula here is returning a minimum, a maximum. There's an absolute value, which that looks familiar, and then there's a length. And so this felt very different than what I had. So I had to investigate this a little bit. And actually down here at thindle.com, square-shaped shaders is this kind of methodology by which this library is drawing polygons. That can be found here. I followed that link here to thindle.com, and we've got an article here that actually basically kind of walks through that code, which is very useful. So I'll let you guys also kind of walk through that code if you want, but we're going to briefly just walk through this rectangle code here because that's what we're going to use in our ShapeMaker plugin. And this is courtesy of Andrew Baldwin. So kudos to Andrew. Thanks for doing this. So the idea here is that, also I'm going to use this desmos.com graphing calculator to help visualize just the formula in 1D. So the idea here is that, let me go ahead and just copy and paste this function, and let's call our new function rectangle rounded edges. Rectangle rounded. And what I'm going to do with rectangle rounded is first I'm going to strip out steps just so that we can see the gradients. And then down here I'm going to make a new rect that's going to be rectangle. It's going to use our new function that we're creating, and I'm going to do something quite similar. I'm just going to copy and paste these arguments, and then I'm going to comment this one out so that we can just use this this function as we work on it and keep that function right where it's at. Okay, and I'm going to go ahead and get rid of the references to step, which means I also need to get rid of the references to width and height. So we're back here. Okay, so why do I want us to take us back here? Well, as it turns out, we could just kind of add to these values if we wanted to. So this absolute screen space. Something else too, absolute will actually run, it will operate on a vec2. So we could just say the shape is equal to the absolute value of screen space rather than having to pull it apart to its separate components, and then we'll return the separate components summed right there. And float shape return, and I'm calling this a float, which means of course I need to make sure that's vec2. Very good. Okay, so this has simplified things quite a bit. And now what I can do is actually just go ahead and I can subtract some value from this. So let's go ahead and let's subtract like 0.5. And I'm going to do that, and maybe that's too much. Let's go 0.15. There we go. Okay, so let's do 0.05. And as you can see, it's pretty clear what's going on here. It's actually just kind of extending 0 out that way, right? Like the center, as we add to this absolute, like 0 is moving that way, and then 0 is also moving that way. And when we add them together, it gets this interesting kind of sliding effect, right? Because it's actually 0 is moving in that direction, away from the center point. Okay. And then the second part of the step from the Thindle formula is to run all of this through a max. Now we haven't looked at max yet, but like absolute, it's really easy to understand. Max, basically what it does is if we give it two values, it'll return the one that's the larger of the two. So it'll compare the values and give you the bigger one. And it's a way to limit. And min, by the way, gives you the smaller of the two. So one of these would return 10.0 and the other one would return 0.0, for example. And as it turns out, you can actually say min and max. So min, the minimum of the maximum of a value. This is really common. You're probably going to see this as you run across programming a lot. And what this is doing, and this is like two arguments, and then the max would, your initial value, and let's say 10. And I think I have those. Let's go to 0.0 with a minimum of 10, say. So this construct is sometimes called a clamp. And actually, you don't even need to write it as min-max, even though that's what they've got in the formula on Book of Shaders. Min and max can just be combined with clamp. And clamp will make sure that a value doesn't go above or below a certain threshold. And if it does go below that threshold, it'll just retain that value. If it goes above it, it'll just retain a top-level value. So that takes two arguments. So let's say we wanted a value to go, once again, between 0 and 10. That would look like this. And so that's really useful. So that's what we're doing when we're doing min and max. And probably this is also maybe easy to say if we just need to graph this. So let's go ahead and see if we can actually kind of build the shaping function of what they're talking about over there, just using Desmos. Okay, so first of all, I'm just going to go ahead and type in an x here and graph x. And a couple things. You can actually use a lot of the same calls in GLSL just right in here in the graphing calculator. So that's pretty cool. For example, here I'm taking x and multiplying it by x to create an exponential function. And this is probably also something that we've kind of seen before. So let's go ahead and let's just start with x. And let's go ahead and see if we can kind of follow through the logic of what's happening in our code. So the first thing we do is, and I'm just kind of doing this as a 1D. This is like a 1D representation. It's going to be 2D in our code. So the absolute value of x, screen space x, and then I'm subtracting by 0.5. So I'm like I'm subtracting 0.5, and now this is why we're going to call in a max, because we want to cut out where it dips below. And I'm going to zoom in a little bit. It's a little easier to see. We'll give ourselves to about 1. There we go. So if I can get rid of this, that value, if it dips below 0, that's what's currently happening actually in the middle here. That's like -5. And so that's why we're going to run our max. We're going to say like, hey, return, if it's less than 0.0, then return 0.0. So this, remember, it's going to return the larger of the two numbers, and most of the time this is larger than 0, but sometimes it dips under. So we can see right away, actually, this is actually going to be the center of our square. That's actually the center of our rectangle, kind of in here, inside that area. And then this is going to be pretty simple. Let's go ahead and let's assign this to a shape, say. So I'm going to give that a letter S for shape. And let's add an item, and let's just take shape and multiply it by shape, and that gives us that nice easing once again. And then what I'm going to do is run a minimum over the top of all of that, and I want to have a minimum of 1.0. There we go, and that's going to limit it on kind of on that side. And let me turn that off. So you can kind of see what we're making here, right? Like normally this would maybe be kind of like a step. Like that's, if we're doing step, we're actually just cutting it off, and we're actually kind of building just something smooth in the middle there. Yeah, so that's where the minimum is coming from. That's where the maximum is coming from. And as it turns out, instead of doing what I did, which was exponential, you can call length again. So let's take this whole thing and let's follow that kind of formula. Now that we've got it kind of visualized in our head what we're doing, let's go ahead and let's run max on that whole thing. And max is going to be okay. So max needs to be run on. This is returning a vec2 shape, so we're going to want to work on this on each individual component, right? So, oh no, I'm sorry. I forgot to just put in the other argument, max of 0.0. And let me make sure that my brackets make sense, or excuse me, my parentheses make sense in here. There we go. That's kind of interesting. Notice the result that we had when we're, adding these two things over the top of one another. I think maybe it's a little easier to see if we just return shape.x. So with the max, it throws away all the negative values, but it also means that it's just kind of almost drawing a line in the x coordinate where these are just going to be held values going that way and held values going that way, and then where there's the intersection, that's going to make a little mini kind of like screen space, kind of like what we had before. So everything that's this offset, that's inside this offset, is just going to be like a gradient. So if I add them together again, you can kind of see that this is just a gradation that way, that's just a gradation that way, and then starting there is kind of going to be like the edge of what we had before as far as our screen space is concerned. Great. So next I'm going to run length on all of this. So let's take our shape and let's run length on screen space. And I'm going to put this inside a new float shape. Let's just call this rect, I guess, for now. And that's going to run the very similar what we did when we called length. You remember we ran this when we made our circle, and it returned something like a curve. And when we did it with a 0 to 1, our curve was the whole screen. And then when we reset everything, then the curve was kind of in one quadrant, and then we could make that be a circle because it's in the center. And now when we do the same thing here, something very similar, it's going to actually smooth out all those edges just like we had before. So essentially we've got a code that's kind of making this inner area on the x and on the y, and then this is giving us a rounded length for these 4 edges. And then the last step would be running this whole thing through, let's say rect is equal to rect. Let's run the whole thing through a step. And I'm just going to step write it. Let's do 1.0. There we go. And we can really see what's going on here, right? Like we got the edges there of the curves and then these straightaways. So that's the idea behind this thing. We can also rewrite all of this using their formula. They've actually just taken some of these things and kind of combined them and rearranged them a little bit. I also want you to notice that, you know, there's a relationship between this number, right? If I have that, I can slide it in and slide it out. And then also the amount of curviness, right? Like, so the amount of that curving, I could also kind of adjust, like if this was a lower number, but then this was a higher number, you notice that. So that's ultimate in curviness, but then if this is 0.5, and then this is lower, this has to be lower than 0.5. There we go. I can adjust the amount of rounding that I have. So let's go ahead and let's rewrite this using their formula. And I'm going to call this just rectangle, actually, which I think is a good name for it, because a rectangle can either have rounding or not have rounding. So I'm going to actually replace this kind of simpler rectangle that I was doing with this rounded rectangle. And let's go ahead and let's get our arguments for what we want to pass this thing. We need to, our new rectangle, our brand new rectangle function is going to pass in the screen space. I want a width and a height. And I'm also going to, I could, instead of these being width and height as floats, maybe I'll actually pass them in as a size in separate components. And then I'm also going to change that number there in relationship to that number there, so I can adjust the amount of rounding. So let's just go ahead and start copying this up here. So the distance is equal to the absolute value of the screen space, subtracted by the size. And then I'm actually going to come in here and I'll subtract the size from the amount of rounding. And I'm going to cast that as a vec2. One more thing I'd like to do is I want to be able to move the screen space around so that I can change position. So vec2 position, and I'll subtract the position here. Okay, very good. And then let's go ahead and let's create a float for the rect. And we'll do the same thing here. We'll do basically the length. But we're going to do that we'll do the minimum and maximum that we did before up here. We'll go ahead and we'll return it down here. So rect is going to be the, let's see, the max of the distance of x and the distance of y. So we'll compare those two and return whichever one is larger. And then we'll do a minimum. And we'll do 0.0. So that'll return actually our rectangle. And then we'll add the length of the distance and the maximum value of the distance, so that we won't get any negative values, so that will be 0. And then we'll subtract the rounding. And then let's return rect. Okay, fingers crossed. And let's see, rect is going to be equal to rectangle. And I'm going to pass in screen space, and now let's pass in our new variables. So first we're going to pass in position, and let's just make we'll just make this position be 0, And then let's pass in our size. And let's make that be 0.4, say, and 0.2, just some arbitrary numbers. We can dial these up and down, and of course we're going to make sliders for these later. And then let's do rounding of, let's do 0.01. And then in here, let's go ahead and just pass in those variables: position, size, rounding. Okay, and this is given an error because I've got too many commas. And there we go. So the one thing that it's not doing right now is it is 2.0 is kind of big. Let's do 0.2. There we go. And it's not doing the step. It's just returning just the pre-step. So we can decide now if we want to do the step or assign this as a vec3 to pass in all the color information the same way we do as the ellipse. And so I'm going to have to kind of decide if I want to do that or not, which I guess that makes sense. So let's pass in a screen color, fill color, and then I'm going to just make a vec3. That's the rect multiplied by the fill color. And then I'm going to change this to a vec3 so that it returns a vec3. Okay. And then down here, rather than pack the vec3 in there, this is now returning a vec3, so I need to make sure that's a vec3 here. And then I should just be able to put rect right in there. And then let's give it a fill color. And fill color is equal to, let's make this be yellow. And let's see, I put it at the end, and I'm going to have to check my order of my variables for my ellipse just because I want that to be consistent. And it's saying that it is not, it's saying returning rect, so let's see, oh, okay, R is equal to rect, and that needs to be a vec3 that it's returning. And now let's, okay, hold on a sec, float R is equal to, let's bring that up here. Let's call this color and color. And let's go ahead and do the step first. So we'll do the step, and we'll step like a 0.1, say. I don't know, that feels a little arbitrary, but let's go ahead and let's step the rect here. And let's minus R, like that. There we go. That gives us that. Great. We need to make sure that these are good values. There we go. So let's do 0.1 and 0.2. And actually, I do believe this is 0 that we step by, so we get the bottom, just the very bottom of where the negative values are. So basically, this is where 0 happens when we do the max. So this is just the edge of 0. That's why that number is 0 instead of going out, extending out into that gradient. And then this rounding should just then, yeah, there we go, control how much smoothing is happening. So let's make that be 0.5. Very good. And we're passing in a color. So the color is just like we did with the ellipse. This is where we're assigning. So this is where we're doing the rectangle calculation. So maybe this should actually be step rect. I don't know. Maybe more useful. Step rect right in there. That's where we do the step operation and do the threshold on all this. And then when we're assigning the color is where we multiply by the color that we're passing in. And then we return the color. Cool. So in 42 short steps, you too can make a rounded rectangle. obviously, let's see, one last thing we would need to do, which is what we've got going on in the other project, is to, let's multiply this by our aspect ratio so that we can make sure this is returning a perfect square. Oops, and I've reversed it. X divided by y. There we go. Yeah, let's make this 0.2, 0.2. Cool. All right. So we built ourselves a rectangle. And now the next thing I want to do is go ahead and take this rectangle function, and I'm going to bring that back into the rest of my code that I was working on, our ShapeMaker. We're gonna fold that back in, and then what I think I want is probably just a drop down here so that I can choose between circles and squares.